All right, ladies, so this is how this problem goes. There's a lot going on here, and so don't freak out. It'll be okay, I promise. Let me show you how this works. At the very top, you've got a block, and it has potential energy due to gravity there. And then it slides down this incline, and there's no friction at all. So we don't have to worry about friction on that part at all. And then it comes down, and this is where it has the most speed. But unfortunately for the block, it encounters friction as it moves across this surface. And so then it stops at 4D. They want us to go through and derive an equation for the new final position. So what happened? What happened is they said, well, instead of just doing h, we're going to do 2 times h. And if I double the height, so if I do 2 times h, then what's going to happen to our position that we're going to end up at? Am I going to be shorter than 4D? So am I going to be over here? Or am I going to be longer? Well, it would make sense. If I have more potential energy, I'll have more kinetic energy, and I'll have more energy so I can go further. So we're trying to figure out where over here we're going to be. So I made that down here, and it says, what is my position X after I double this height? So what is X? Okay. We know potential to kinetic, and then we're going to lose energy. And why do we lose energy? Well, remember, this energy lost is due to friction. If you rub your hands together, you'll hear a sound, and that sound is energy that's being lost, and on top of it, your hands get warm. That's why you do that. So we're creating friction, which then releases heat energy. So same thing's going to happen to the block as it moves across. What is that? That's called work. So here I said work due to friction is equal to the force of friction times the distance it travels. And we've got to find this new distance. But it's not as easy as it sounds. This is a really tough question. I actually scored this question the year that it was given a couple years ago. And we didn't have a lot of students do very well on Part C because it is extremely complicated. Let's try to make it easy for you though. Before the block falls, so up here, it's got potential energy due to gravity. After the block goes across the surface and when it ends up here, it's lost all of this energy to work done by friction. So we're going from this to this. And we're going to do the same thing, but what I've done is I've done it in 2 different places. I did it for our original height. So this is for our original height, and this is for double the height. And that's what they want. They want to know how far is it going to go if you double the height. Well, unfortunately, we have to start with the original energy and find out how much work is done by friction just to get to 4D. Once we do that, now we can then use double the height and try to figure out where it goes. So here we've got mgh is equal to the force of friction, and then I said times 4d because notice it's 4 times the distance. It says 4d, so that's what our distance is that the friction acts over. We also know the force of friction is equal to the coefficient times the normal force, and if you remember when you draw a free body diagram like this one, we have mg down, we have normal force up, and so the normal force is equal to mg. So now we've got mu b times mg. So what do? I rewrite my mgh that I had here, and then instead of force of friction, I have to write what I came up with right here, and that's mu b times mg. And then remember we had the 4d and it stays right where it is. That's that distance that I travel with friction. The great part is mg crosses off, and I'm left with h is equal to mu b times 4d. But they said I can't have h. I have to have my answer in terms of d. So in order to do that, I'm going to have to go way up here, and I have to look at my triangle that I have. So you'll see the right triangle here. The left side or the opposite side is h. Then the adjacent side down here is the distance. And if I want h in terms of d, I'm going to have to use trig. So here's my angle, and I have the opposite and the adjacent side. And if you remember, tangent of the angle would be equal to the opposite, which is h, over d, which is the adjacent. Now I can solve this equation for h, and that gives me d times the tangent of the angle. So now wherever I see h, I have to plug in d, tangent of the angle. So this h becomes d, tangent of the angle, and that's equal to mu b times 4d. Oh, but look at this. My d's cross off, which is great, because now tangent of the angle over mu b is equal to 4. And that's where I'm going to stop with the with this original. Now I'm going to double the height. So I come back up and I say, well, now instead of the block starting here, I'm going to start way up here. So it's even further up because it's double the height. Now instead of just h, I have 2h. And I'm going to make a little h here because that's what we've been using. So I've got mg times 2h is equal to mu b times mgx, just like I had when I did this. But now x, remember, is that new distance that I slide. And that's what I'm looking for. I'm trying to find something for x. We said that h was equal to d tangent of the angle. So we put 2 times d tangent of the angle. And then I moved the ub, divided both sides by mu b, and I get x is equal to 2d tangent of the angle over mu b. But remember, we said tangent of the angle over mu b is equal to 4. So now I'm going to take that 4 and I'm going to put it in where I have tangent of the angle over mu b. When I put that 4 in right here, 4 times 2 is 8, and that is 8 times the distance, and that is equal to how far it would slide. That's a lot of work. And it's not a ton of points. I think that part is maybe 3 points from what I remember. If I go into AP Classroom and I actually look at that part, it is 3 points. So where in the world do you get 3 points for this great big huge explanation, okay? Which I'm not even sure is worth trying to do, but you know, it's up to each student as to whether you try to attempt something like this. So this is one that not a lot of students did. You get 1 point. So let me make a copy of this guy here really quick. So I'm going to do this, and then I'm going to make a copy. Okay, so I made a copy. Let's see if I can paste it in. I'm not sure I can. So, there it is. So here's where you get your points. You get 1 point for indicating that the initial energy of the blocker system for the new ramp is twice that as for the original ramp. So we did that right here. So where we have 2h. 1 point is showing the frictional force remains the same. So here's the friction force. It's still mu b mg, mu b mg. And then you get 1 point for equating the gravitational potential energy to an expression that shows the energy dissipated by friction. And that's really this. But to get all those points, you have to do all this work. And that's the unfortunate part. All right, so that's my 9-minute explanation for this really difficult problem. That was a great question. See you later.